Welcome to the workbench. So today I have a Raspberry Pi 4 and let me remove the little memory card because otherwise I'm going to forget about that. Raspberry Pi 4 is touted as the first PC desktop-like class computer from the Raspberry Pi Foundation. Some of their past Pis have worked pretty well for that purpose, but they always had little issues here and there that kind of make them not great as a PC replacement for a lot of people. Like, they didn't have very good I/O, they didn't have gigabit Ethernet, lots of little things like that. The processor wasn't quite fast enough for a lot of things. It couldn't do 4K. It was hard to do 2 monitors, or at least do it well. So the Pi 4 overcomes a lot of those. It has 2 HDMI ports, although they're like micro HDMI, which it's harder to get adapters for that, and then you have a lot of dongles. It has USB 3.0. It has a dedicated gigabit Ethernet chip now that lets it get full gigabit, so that's a lot faster. The Wi-Fi is improved. A lot of little improvements make this actually a very nice board. One thing that I have a gripe with, though, is the official Pi case, which I do like this case. It's very simple. It looks nice. It matches their other hardware, their keyboard and mouse and all that very well. But the problem I have with it is that if you can see here, there's almost no ventilation. The only ventilation that exists is the little cracks between where all the ports are and where the plastic is. So what that means is, as the Pi, with its desktop class performance, generates heat in the CPU and in the power circuits and all these parts, and I recorded some video with my little IR thermal camera of the Pi booting up. It gets really hot in here, and what happens is all that heat that's generated in here, it tries to rise and it can't. So it might have a little bit of convection inside and kind of come out a little bit, but I was noticing when I was doing my testing that certain parts were getting super hot. For instance, when you have the little card in here, I was doing some testing of the card performance, so I'd grab one out and I would notice that the actual card itself was really hot. And I noticed that the USB ports were hot because they're metal, so they're conducting some heat out. Everything was really hot after I was doing some standard benchmarks and testing and things like that. So it really needs a fan. I really wish that they had the option for a fan in this case, or some cutouts or something that you could do for ventilation. Even if they had some ventilation holes or something to let that heat go out. So what I did was I found there was a Redditor on Reddit who had he had modded his Pi case to add a fan. It wasn't this exact fan, but it was one like it. This is called the Pi fan, and I found it on Amazon. I have a link to it in the description, but you can get these from other places too. They have them on Adafruit and CanaKit and other sites. But this is the Pi fan. It's a 5-volt fan that you can plug directly into the GPIO pins on the Pi. So it's also nice and small, so you can fit it inside of a case. And it's a pretty standard size, so some cases even have holes lined up for this fan already. And it has 2 wires. There's a black and a red. The black is for ground and the red is for power. So when you plug this into the Pi later, you'll plug the red one into pin 4. It's kind of hard to make out on there, but there's a diagram available online that you can look at for what pins. And the black one goes into pin 6, and that way when the Pi turns on, this fan will come on. Also, I have it pointing up to pull air out from the Pi instead of pushing it down in. A couple reasons for that. One is so that dust would kind of come out and not be sucked into the Pi. There will still be some dust that accumulates over time by the ports and things, but in general, I don't like blowing the dust directly onto the CPU in this area. But it's, either way is going to be about the same cooling factor and efficiency, so it doesn't matter on a computer like this. So once I get that off, what I want to do in this video is show you how I'm going to put this fan in here. The Redditor kind of mentioned he made a hole in this case, but it might not be obvious the best way to do that, and I'm going to show you the best way to do that. First of all, I'm going to need some support for this when I'm making the hole, so one thing that you'll want to do is put it together, but you don't want to have the Pi inside. That's a bad idea because you'll make a hole and then accidentally drill into your Pi or something. Don't want to do that. So I'm going to take the Pi out of here, and I'm going to put the case together. And there's a few different ways you can do this. One way is I have a Dremel tool in this kit that I got on a Black Friday sale for like 15 or 20 bucks or something, and it has all these different bits. You can use the Dremel. This is a drilling bit. You can actually drill with the Dremel. Do it on a low speed because this is plastic, and you have to be really careful. What you can do is mark the hole and then drill a little bit inside with this bit, and then you can take, if I can get that bit back in there, I'll just do that later. Then you can take a sanding disc and kind of sand the edges down to where the mark is for your hole. And to mark the hole, if you're going to do it that way, there's two ways. One is you can take the fan and kind of make marks on the outside and then draw a circle on the inside of that using like a compass or whatever. You can also just set a 1 1/8 inch hole and mark that on there. It's a little hard because the surface is not entirely flat. And also that's a reason why I would rather use a drill bit for this. Now drill bits have a problem in that a lot of times you might have a spade bit, which looks something like this. And these bits are not that bad. You would need a 1 1/8 inch bit. You can see 7/8 is a little bit too small for that hole. And you want to have it as close to this diameter as possible. Spade bit could work, but it's not very easy to control in plastic. These are not that great for plastic, especially if you need to drill slowly, which we want to do. If you drill too fast, the plastic is going to overheat. So instead, I went to the hardware store and I found this bit. It is a hole saw, and hole saws are good for a lot of different types of cutting, especially for metals and plastics, because they have this round part with lots of teeth on it. So you're going to get a lot of even cutting force, and it has a middle kind of a guide to pull it in. And it's a little tough still, even with this, but it's the best way to get control. Another thing is on your drill. So I have a DeWalt that has two settings for if you want a little more torque and a little slower speeds, you can go to, I think, 1. So if I switch it to 1, even if I go fast, the chuck is rotating a little slower. If I go to 2, it's going to go super fast. But I don't want to go super fast. I just want to go a little slower so I can do a little more controlled cut. If you go too fast, you're going to burn the plastic, you're going to ruin the finish on this thing. Now, if you're cutting it with the Dremel, you're going to have to make some markings. Since I'm going to cut this with the drill bit, I just need to make sure I'm centered, because this part of the bit is actually going to be doing the cutting for me and pulling the rest of it. And I know that this 1/8 inch bit is almost the perfect size for that fan cutout. Can't really tell exactly, but I measured it earlier with my ruler, and that's where I came up with this bit size. You can go a tiny bit larger if you absolutely need to, but this is the right size. Another thing I'm going to do, this is a larger hex shank than I have for my quick change, so I'm going to have to put this directly into the drill's chuck. And I like doing that when I'm doing any kind of precision work anyways, because when it's directly in the chuck, you have a lot more control, and it's a lot more stable spinning. The more things you have sticking out of your drill, the less control you have at the end of that. So I'm going to clamp that down, and at this point I'm going to drill into the pie. I'm going to do this a little offset so you can kind of see. Those are the screws for it, and this is also going to get a little messy. There's going to be some plastic shavings. So I'm going to try to be right in the center on this side. I don't want to do it over here because that's where all the USB ports are, and the fan would not fit there. So I'm going to put it as close to center as I can. I think that's pretty good. And then I'm going to go ahead and go slow. For this first hole that's in the middle, you can see that these teeth aren't engaging yet. The ones are on the edge. So I can go a little faster just until those get started. But I'm going to hold this pretty steady. You can wear gloves if you're a little worried about not being able to hold it steady. But I'm going to grip the pie and go ahead. Woo! Like that. That's exactly why you have to be careful. So, like I said, it's a little bit unwieldy. But this time, I will go a little bit slower. The problem is that this center bit is going to try to drive in there because it's catching on these pieces of hard plastic. So you just have to be able to counteract that. So now I'm going to go slowly but steady. I try to go as flat as I can. And now I'm through, and as I said, there's all kinds of little things. I have a little dust can here that I'll kind of get this stuff off of here. Make my workbench a big mess, but that's okay, I can clean it up later. So I got out that disc, and there's probably going to be some burring inside of here. There. Alright. So we got a hole, and it has some burrs on it. It's a little bit hard to see, but I'm going to go ahead and sand those off. So I have a couple different kinds of ways that I can do sanding to make this pie look a little nicer, because right now you can see there's a little bit of flaking on the front from when it was kind of jumping around. It's a little rough on the inside. So I'm going to take a couple pieces of sandpaper. I have 120 grit, and then I also have 600 grit. If you really want to do a professional, really nice job, you might want to go for like, 80, then 120, then 200, 220 or whatever, and go stepping up like that, but I'm going to do this a little quicker. So I'm going to always start with a lower, more coarse sandpaper and work your way up. So I'm going to go on the inside here. This is just knocking off some of those burrs from the cut that I made. So we're doing that. And then I'm going to go on the loop here. It's a little easier to use these. You could use a sanding pad or something like that, but strips of sandpaper are usually a little easier to control when you're doing more fine detail work like this. Alright, and now for the outside, I'm not going to rub on the outside because that can ruin the pie's finish. I can scratch it up. So I'm going to do it through the middle, through the inside here. Of course, I'm tearing up my fingers on the back of this pie case, which is highly annoying, but that's okay. All for the sake of this video. If you like this video, you might want to subscribe to my channel. I'm planning on doing some more videos with Raspberry Pis, some of the things I do with the Kubernetes cluster of Raspberry Pis, other Pi hacks and tricks and tips and things. I know there's tons of other great YouTube channels out there for Pi stuff, and I'm not particularly a Pi person, but I do a lot of stuff with Pis and hobbies and open source and all kinds of fun stuff like that. Alright, so I got that one. I'm going to knock this off with the blast it with some air. You can see there's still a little bit of scratchiness up there. Hopefully this sandpaper will take care of some of that. The 600 grit. 600 is almost like, it feels almost like paper on both sides, but it kind of more polishes than sands. And that's why you'd want to do, if you're doing a really professional finish, you'd want to step up from one sandpaper to another. But 600 can make this plastic actually almost shine, so it looks like it's a factory finish, which is nice. But for this video, I don't need to go quite that level. And again, I'm going to round out the top a little bit like this, just to make that top edge not be super sharp. It's also good for airflow to not have sharp edges and burrs and things, because anything that disturbs the airflow is going to cause the fan to be a little less efficient. Alright, so that's pretty good. There's still a little burring over here that if I really wanted to spend some time on it, I could make that look a little nicer, but we're looking pretty good so far. And that's going to be where the thing is. At this point, though, I need to put the holes in to mount this fan, which I blew the fan away, so it's over here now. So I'm going to put the fan down. It's going to be oriented like this, so that these wires can go over to the GPIO. And I'm going to take my pencil, and it's easy to do this with a mechanical pencil because I can stick the lead out a little bit. So I'm going to line this fan up with the hole that I drilled out as close as I can, and hold this down like that. Now I'm going to put 4 markings where I need to drill screw holes just by going around inside the hole. And last one right here. Alright, so I got 4 marks. I'll put that aside, put this pencil aside, and I'm going to take this hole saw off my drill because I don't want to make a hole that big. And I'm actually going to use a teeny tiny drill bit. What I try to do is find a drill bit that's very slightly larger than the screw threads on here. That way I can stick the screw through without having to thread it through plastic. Threading screws into plastic is not that fun. I believe last time I tried this out, it was the 7/64 inch bit that I used, and it looks like that's just a hair bigger than the threads. So when I drill the hole, I'll be able to stick this screw in there, put the fan on the back side, and then use these little itty bitty nuts to secure it in place. So I'm going to take that 7/64 bit and stick it in the chuck. And again, I like to put things, when I'm doing detail work, directly into the drill's chuck, because if I used something like this with a quick change bit, it would wobble a little bit, or as AVE says, it would weeble wobble, and you don't want to have weeble wobble when you're doing detail work. So I'm going to put that in the chuck, tighten it down, and let's drill these 4 holes. Again, I'm going slow, because if you go fast, you're going to burn the plastic and it's not going to drill nicely. You can even see how it's kind of a harder plastic. It doesn't even come apart because it slowly melts as you're going into it. I could even go in a tiny bit slower if I wanted to. Okay, 2 holes, 2 to go. And last one. These holes, depending on how accurate you want your little fan to be stuck in there, you don't have to be super precise since they're going to be a tiny bit larger. And there's more burrs inside because of that drilling that I just did, so I'm going to take this coarse paper again, just knock those off like that. Just make it so the fan can sit flush. This one's still stuck in there. There we go. And again, I'm not doing this on the outside surface because the outside surface is a little nicer. The inside, I'm okay with scratching it up a little bit. All right, I'm gonna blow this out. Get these guys nice and clean. Make myself get all kinds of plastic flakes on me. And then I'm gonna find where all these screws blew off to. There's a nut up here. 1, 2, 3, 4 screws. And 1, 2, 3, 4 nuts. Okay. So I'm going to stick these screws in here first. 1, 2, 3, 4 screws. Put this fan on, and again I'm going to orient it like this so that these wires can go right around to the GPIO pins, not be in the way of the airflow. In fact, I'm going to blow off this fan too because it's got a little bit of plastic dust on it. All right, so put the fan in, line up those holes. And this is going to be the hardest part of the whole thing for me because I do not have tiny fingers. Getting these teeny tiny nuts to go onto these screws. If I even can. Last time I did these things, I think these are like M2 or number 2 or something. They're teeny tiny metric screws. Maybe 2.5. They're just so small. 2. Now to tighten these down, I actually need my little itty bitty eyeglass screwdriver, because those are pretty small. So I'm going to grab that. Alright, this thing I think I got in an eyeglass kit years ago, and it's actually my favorite small screwdriver. I have a set of really nice ones, but this guy fits almost anywhere. It's sturdy enough. It's just a nice little screwdriver. Sometimes your favorite tools are not the ones that everybody else seems to think are the best. Alright, so I'm just tightening these up, just holding the nut on the back and then tightening up gently, not using a ton of pressure. Because this fan, it's not like it's going to be throwing hundreds of CFMs and need to be bolted on to not take off. It's not that powerful of a fan. Alright, so it's screwed in, and now I'm going to take the Pi, put it in the case, and I'm going to go ahead and put these pins, the plugs, the barrel plugs, onto pins 4 and 6. So the red goes on 4. Whoops. Red goes on 4, black goes on 6. Make sure they're down all the way. And then that cable wraps around, and put this in. And now we have the fan on the Pi. Let's go see if it works. Alright, I'll plug it in, and looks like it's working.